I am joined for our pre-concert talk this evening by a very special guest, one of the newest members of the astronomy faculty, Dr. Robert Moorhead.
Thank you very much.
I've asked Dr. Moorhead to come here and speak a little bit about some things that he's interested in, our solar system, and to give us give you a little bit to chew on for what we're going to hear and see during the performance tonight. Indeed, this screen that you see above us on our left, your right, will actually be on during the performance, and you'll get to hear a little bit about some of the imagery and some of the source of the imagery and what will accompany our journey around the solar system. So without any further ado, Dr. Moorhead.
Thank you very much. All right, so can everyone hear me okay in the back up there? Sounds good? All right. So as Philip said, my name is Dr. Moorhead. I am the director of the Preston God Observatory here at Texas Tech University. And I have to be honest with you, this is like kind of a fantasy come true. I've kind of always wanted to be the guy who gave like the talk before the Planet Suite. And so like when I got asked, I was like, yes, let's do that. That sounds great. So I was really, really excited, and a lot of times when people do the Planet Suite, they have an astronomer come down, they talk about the solar system, and show you all kinds of pictures from NASA. And that's exactly what we're going to do today, because I'm not that creative. But as I was doing a little research, and by research I mean checking on Wikipedia real quick, not what you should do for your classes if you're Texas Tech students, I got really interested in the whole idea behind why did Holst write the Planet Suite, right? What was it that he was trying to say? And I was kind of disappointed, actually, when I found out. Because to me, I'm an astronomer. I study space and things in space. And I get really excited about it, or else I've made a terrible life choice. And so I was a little disappointed to find out that Holst wrote this piece not from an astronomical perspective, but from an astrological perspective. Half of you just said, what's the difference? So, right, astronomy is the study, the science of studying the contents of outer space, whereas astrology is using the positions of the stars, the planets, the moon, and the sun to predict the future or to say stuff about your personality. And so that was what he based it on. I was a little disappointed, as you might expect. But then it occurred to me, like why? Because when we look at the planets, when we do Holst, we get very excited about all the kind of celestial splendor that we now know about the solar system. So why didn't Holst feel the same way? Why did he go for the astrological perspective as opposed to the more scientific, the astronomical perspective? Well, I thought about it for a while, and I realized that we live in a very kind of the golden age of astronomy. We have space telescopes, we have electronic detectors, we have massive space missions that can collect exquisite data. We are literally going through a renaissance in what we know and understand about the universe. Back in 1916, when Holst started writing the planets, this was state of the art. A guy looking through a telescope, right? Now, there was astrophotography by this point, but it wasn't really well-defined and well-developed. We were still kind of in a very early age of astronomy and astrophysics as a science. And so, we've gotten used as a generation of looking at beautiful Hubble pictures and seeing these vast vistas of space. Back then, things weren't nearly as nice. You had black and white photographs or sketches from Earth-based telescopes that couldn't see the heavens very well. So that might be fun for today's talk to kind of compare what the conception of what these planets would be like as objects in space back in Holst's day to what we now know what the solar system is like. I'll go in the same order that he goes through the planets. Those of you who have taken Astronomy 1400, which you should if you're a Texas Tech student, you need a general and science credit, what you'll see is kind of like what the state of the art was. So let's start with the very first movement, Mars, the bringer of war. Now, the picture I just showed you, the guy with the telescope, that was Percival Lowell. And he was a very rich guy and basically founded his own observatory, and he was very interested in life on Mars. This is one of his sketches. This is sketches about 20 years before Holst wrote The Planets. And this is kind of very famous because this is Percival Lowell's Canals on Mars. He thought that Mars was inhabited, that there was a dying world, a dying civilization, as their planet was drying out, had to build these big canals to get irrigation across the planet. Interesting to note, if you actually look at those sketches and look at the size of the details on it, there is no way he could have physically seen any objects, if they were there, with his telescope. His telescope did not have enough resolution to notice fine detail. This is an example of kind of wishful thinking. So, of course, Holst, writing from an astrological perspective, he associates Mars with like the Greek god Mars, the god of war. So Mars is kind of this ominous figure that brings war and causes aggression in the hearts of man. But it's kind of interesting. So here's now our modern conception of what Mars is like, the red planet. Right? You see, it's a kind of a dry, arid, dusty place. It has a very thin atmosphere, but we see some things we recognize, like that polar ice cap. Turns out, of all the places in the solar system, Mars is probably the easiest place that we could live besides the Earth, right? You don't even really need a spacesuit. If you had a really good, if you had a breathing mask and a really good parka, and the radiation didn't get you, you might be okay in some places on Mars. Mars is also very interesting as it may be a place that could conceivably support life, maybe in the past, or even possibly still today. I mean, Mars is probably the most Earth-like of all of the planets other than Earth in the solar system. I mean, we can always play one of my favorite games, Arizona or Mars. I mean, even the sky is blue in this picture. Sometimes the sky is blue on Mars if there's not much dust in the atmosphere. This actually is Mars. Now, this is an interesting picture. This is a relatively recent picture from a NASA orbiter. And this is actually showing these dark streaks that appear seasonally on Mars. These may be associated with a very salty, briny liquid water that might occasionally come up out of the topsoil and actually still flow. Now, we'd be very interested in water on Mars because the one thing that we know about life on Earth is that all forms of life, no matter how small, how hardy, strange environments they can live in, all require liquid water. So we're always very interested where there's liquid water when we start talking about the possibility of life outside of Earth. So Mars, we know in its ice cap, has ice. We know it has subsurface ice. And it may even have liquid water. Now, if we look at some of the features on Mars, we see evidence of erosion. We see old geographical features that correspond with water. So we know that Mars had water in the past. So it could have potentially hosted life in the past as well. Okay, so let's talk about Venus. It's interesting, with some of these, Holst's view of the planets kind of corresponds with our modern scientific view of the planets. Venus is not one of these. Venus, the bringer of peace. This is a sketch from a popular science book in about the 30s, actually a little bit after Holst wrote the planets. And that's about all we knew for decades about Venus. Venus is kind of inscrutable. It's always covered in clouds. The entire atmosphere is completely opaque and completely cloudy. This is actually an infrared image on the left that's showing some of the wind structure. And until the 1960s, when we sent spacecraft to Venus and actually beamed radar waves down to the surface, that we were actually able to map Venus. So Holst sees Venus as the bringer of peace, kind of associating it with like love and Aphrodite and that kind of stuff. Venus is also sometimes called Earth's twin. In size, composition, mass, it is exactly duplicating Earth, except one tiny little thing. Its atmosphere is about 90 times more dense, more heavy than Earth's atmosphere. And due to the amount of carbon dioxide that's in Venus's atmosphere, the surface temperature is about 700 degrees Fahrenheit. Venus, quite literally, is a hellscape. It's not the bringer of peace or the goddess of love. It's basically hell Earth. Imagine if you could stand on the surface of Venus, if you had some magic spacesuit. If you held a block of lead in your hand, it would melt like a stick of butter on a summer's day. Now, what's more amazing, this picture is actually from the surface. This is an actual photograph from the surface of Venus. This is the Venera spacecraft launched by the Soviet Union in the mid-'70s. It actually landed on the surface of Venus and lasted a whole 20 minutes. And it was designed for that, right? That was a miracle that it was able to last that long. If we're talking 90 times atmospheric pressure and temperatures high enough to melt lead. And Venus, we look at surface, and it is just a dry, arid hellscape. Venus has lost most of its water. That's why we think it actually has become Earth's evil twin. Mercury, the winged messenger. Now, this is one where Holst's perspective on the planets and our own kind of matches up. So this is an early map of Mercury. Mercury never gets very far in the sky away from the sun, so it's very hard to study with a telescope. This is an early map. You can see it's kind of blurry, kind of blobby, not a lot of detail. Turns out Mercury is very similar to our moon in its bulk geological composition, in its bulk geological structure. I mean, it kind of looks like the moon, right? Some of you are wondering if I just put a picture of the moon. But this is actually a picture of Mercury from the Messenger spacecraft. Now, Mercury, why it's always been associated with swiftness or fast travel is because it zips around the sun in about an 88-day orbit. It rapidly changes its position on the night sky. So in this way, Holst's conception of planets and our modern scientific conception of planets is kind of true. Then we get to Jupiter, the bringer of jollity. I think that means being happy. I'm not exactly sure. This is a sketch. Now, I found this in a scientific paper that was written in 1916, right as Holst was starting to write the planets. And the whole point of this paper was to track where Jupiter's great red spot was and map how it was changing over time across the surface of Venus, or surface of Jupiter. And that represents probably one of the better depictions of Jupiter at that time. I mean, it's interesting. It's kind of stripy. You can see some of the features, but it's not terribly inspiring. Now that we've actually spent robotic spacecraft to visit it, we see that Jupiter is amazing. Jupiter is the most planet of planets. It's huge. It's massive. There's more mass in Jupiter than the rest of the planets of the solar system put together. You could cram all the other planets together into one big planet, and it would still be less than Jupiter. Jupiter is what we call a gas giant. It has no solid surface. It has this massive atmosphere with these cloud bands due to its really fast rotation. And very notably, you guys have probably seen this before, that red spot. That red spot is a cyclonic storm, kind of like a hurricane, and it was first detected by Galileo in 1610. So in the past 400 years, I'm getting a little feedback. If you can bring the mic down, please, a little. Thank you. That great red spot has been as a storm. Imagine a hurricane the size of Earth that's been going for 400 years. The other thing about Jupiter is Jupiter hosts many moons. Some of them almost larger than Earth's moon. Some of them that, if they were orbiting the sun by themselves, we'd classify them as a planet. It has a plethora of worlds in orbit around Jupiter. Of course, we have Saturn. This is often Holst called this the bringer of old age. That may have something to do that it takes 27 years, or half a lifetime, basically, for Saturn to orbit around the sun. Of course, Saturn is famous for its rings. Those rings have been known for hundreds of years. Galileo also was the first to detect them. When you're the first person to put a telescope on the sky, you get to make all the easy discoveries. That's actually a picture, and it was taken about the 1920s, about the same time Holst. So that's an actual photograph from that time period. I like this one. This is a backlit view of Saturn from the Cassini spacecraft. It looks kind of weird because the rings are in sunlight still, and they're actually illuminating the night side of Saturn. That's why it kind of looks weird with those dark bands kind of in the middle. And if you were to squint on your computer monitor and could actually see, you are actually in this picture Because right about, of course, the laser pointer works every time beforehand until we get to the actual talk. So let's try the other laser pointer. There we go. So right about there is a pale blue dot, which is actually Earth kind of photobombing Saturn in this picture. So you're actually in it. If you were looking up and waving, you're technically in that picture. So I'm going to do what a lot of people do when we start talking about, Uranus and Neptune. We have to kind of throw them all together. So there's two movements in the planets for this: Uranus, the magician, and Neptune, the mystic. And in this sense, at least for the time, this kind of makes sense. At the time, we really didn't know much about Uranus and Neptune. They were tiny little disks that you could just barely resolve in the aperture of your telescope. We could tell they were kind of blue. From their gravitational interactions in their orbits, we could kind of work out their masses. But that's all we knew about them. Until, in the 1980s, I remember this when I was a little kid watching the live feed from Voyager 2, we actually got our first close-up looks at them. Much like Jupiter and Saturn, they're gas planets as well, with no solid surfaces. And a really pretty blue. I really like Neptune. It's that color blue because it's further out from the sun, and so the amount of solar energy changes the chemical makeup of its upper atmosphere. Also, when Voyager was flying by, it had that big dark circle that looks like a storm. That's a storm like the Great Red Spot. They called it the Great Dark Spot because astronomers not good with names. And we actually know that it's not going to last hundreds of years because it's already dissipated. We have new imagery with Hubble that shows that the Great Dark Spot isn't there anymore. It just happened to be there when Voyager was coming by. So, kind of talked about how Holst was kind of inspired from an astrological point of view. Got me to thinking, what if Holst were writing the planets today? Now that we have a complete census of the solar system, that we actually have this information about these worlds as actual physical objects. So I'd like to imagine what it'd be like if he were today. Now, one thing, he might add a couple more, right? Because one thing you might notice if you look over the program is there seems to be a planet missing. It's my favorite planet. I like it a lot because I live here and I can breathe. Right? Since he wrote from an astrological point of view, he left Earth out. But from an astronomical point of view, I don't know, I think I would put it in, right? Now, this is a pretty amazing photo, right? This is taken from a spacecraft that's a fairly large distance away from the Earth, looking back. We didn't really start getting images of Earth like this until the space race in the 1960s. And that's the first time we could actually see the whole Earth as a single planet, a single space, a single place floating in space. Now, that's a pretty powerful image, right? I mean, it's our only home. And it's kind of gorgeous, really. So I'd like to think that if Holst were writing today and taking a more astronomical perspective, he'd put the Earth in as well. Okay, we're not going to put him in. That's Pluto. That's a dwarf planet, right? We reclassified it about a decade ago for very good reasons, and that's a whole other talk. But, you know, even though it's not a planet, it's still a dwarf planet. And Pluto is a very interesting world in and of itself. So maybe he would put that in. Now we get to the part of the talk where I start pitching my own research. So I work in a field called exoplanets. So the planets I actually study as part of my research are planets that orbit other stars. Stars that are different than our sun, that are all throughout our galaxy. Most of these planets we can't observe directly. But there are a few where we can. And here's a video showing them. So this is a planet with this is a star with the best name you're ever going to hear. It's HD 8788. But what you're seeing are 4 planets. Those planets are about the size of Jupiter, if not bigger. These are planets that are young and still glowing brightly at infrared wavelengths. They're basically glowing in heat. And we've been monitoring this system for the last few years. Those planets are so far away from their host star. They're actually, all four of them are out further from their star than Neptune is from our sun. But it gives us a rare opportunity to actually see planets orbiting around another star and actually image them. With indirect methods, like watching a star dim as a planet passes in front of it, or by carefully measuring the star's motion due to the gravitational influence of a planet orbiting it, we have now, since about the mid-90s, been able to identify a grand total of 3,605 planets outside of our solar system. As a number, every time I give a talk, I have to look up because it changes pretty rapidly. We're constantly discovering new planets, and with new space-based missions that are about to launch in just a few weeks, we're going to find even more. So then I thought, well, okay, let's say Holst was writing the planets now, and he wanted to include all of the planets that we know about, so that would be 3,605 plus 8, 7, 8, 9, depending on how you want to count it. And so taking the average length of a performance of the planets, I calculated how long it would take to play that if you actually wrote a movement for every planet we know about. It would only take 3 weeks of constant playing. So, if you guys want an interesting semester project in the orchestra, there you go. Yeah, so that's all I have for my little warm-up talk to just kind of give you a feel and a flavor for the solar system as a whole. But during the performance, up on the slideshow, are going to be images. All of them come from NASA, and they're going to, for each planet, each movement, there are images from NASA spacecraft, from Hubble, from other instruments that show our current modern understanding. And so you'll see a lot of different things over the course of those images. You'll see some planets that are actual real color images. You'll see others that are in false color. You'll see some in black and white. And for the giant planets, also, there will be some images of their moons and the surfaces of their moons as well. So if all of a sudden Jupiter goes from looking like it has clouds and banding to being a kind of a rocky ball, that's because we're looking at the moons. So I hope you enjoy those images that play while the orchestra goes through the planets. Thank you very much. Normally I'd ask for some questions, but we're running kind of short on time, so I'll go ahead and clear the stage for the orchestra. Thank you very much.
evening's program with a couple quick remarks. First off, we're thrilled you've joined us. We have a terrible problem that's befallen us, and that's that we ran out of programs 15 or 20 minutes ago. A type of problem you never complain about in our business. It's great to see a full house. We're thrilled you've joined us. For those of you who don't have a program, the first thing on this evening's program is the overture to Creatures of Prometheus by Beethoven. It tells the tale of the gods forming man by clay, and then man working against the gods and all of the intrigue that ascends from all of that. I will not be conducting this. I want to draw your attention to another thing that if you don't have a program, you wouldn't know. This will be conducted by Dilyana Lazarova, one of our DMA conducting students here at Texas Tech University. So please help me welcome Dilyana Lazarova. Ladies and gentlemen, since we are missing about 200 programs, again, I'm loving this problem. I can't keep from saying it over and over. I thought it would be another opportunity to hear from our fantastic new faculty member in our astronomy department, astrophysicist Robert Moorhead. Would you please help me welcome the doctor? Dr. Moorhead, would you please just share very briefly a little bit about what our audience is going to see on the screen as we perform, and then perhaps the order and number of the planets that will happen in the suite? Thank you so much.
All right, so just like so you'll notice, if you're familiar with the solar system, or that old mnemonic, my mother just served us 9 pizzas. Oh wait, that's when I was a kid. No Pluto. Holst organized the movements in an order kind of different than we would from the normal order of the solar system. So the first piece is going to be Mars, the bringer of war. And then it's going to move in, skipping Earth, because remember, since Holst wrote from an astrological perspective instead of an astronomical one, Earth is not included as a planet. Then he'll move into Venus, Mercury, and then starting at Jupiter, we'll move out Jupiter, Saturn, Uranus, and Neptune. And so that'll be the order in which the pieces are played. And that'll also be the order that the images that will be in the presentation that goes along with the music will also be. So it's time to go not necessarily in sync, but with each planet. So you'll see as that piece is playing, you'll see images from that planet. Now those images are NASA images taken from spacecraft and taken from Hubble. So some of them will be not the perfectly digitally remastered images. Some will be in false color. Some might be a little blurry if it's an image from a moon as the spacecraft is zipping by it for the first time. But this represents some of the best images that we have of the planets. And they're real scientific data, not just pretty pictures. So you'll see things in different wavelengths of light. You'll see things in colors that wouldn't be detected by the eye. And on some of the planets, on 3 different worlds where we've actually landed a spacecraft, you'll also see images from the surface of those planets as well. And in a few, some of the detritus that we've left behind on a couple. So I hope you enjoy the performance tonight, and I hope you enjoy the images that go with it. Thank you very much.
Without conducting and see how long I'll get applause.